Welcome back to Learning with Ms. H. Today we are in Earth Science doing our rock cycle and igneous rocks focus. First thing you're going to do is always going to be your bell work. So go into your notebooks and give me a short explanation of the rock cycle, what it is, how it works, how rocks change, all of that good stuff. For the rest of the lesson today, you're going to be taking notes on general properties of rocks in the rock cycle, and then you're going to do a short assignment associated with those slides. And then we're going to have our presentation on our igneous rocks focus, and you'll have another short assignment after that. So let's get into it. I'm actually going to do this in order today instead of doing the homework assignments first. So I will try to remember to put some bookmarks in the description below, so you can jump ahead to look at the homework and how to do it if you want to do the slides on your own. As always, you are able to go ahead and pause this video at any time to finish the slide you're on if you're doing them with me. Take it at your own pace, fill in the slides, restart the video, move on. As always, if there are videos included in any slides, go ahead and pause me, watch that video, come back. And the last option is, as always, to go ahead and do these slides on your own and just check out the homework sections. So go ahead and grab your supplies for the day, pause me to do your bell work, get all your stuff together for what you're going to take notes in and on, and then rejoin me. Welcome back. Let's go ahead and get into it. So the rocks and the rock cycle. We've learned a little bit about both of these already. You've learned the types of rocks and some of the basic properties of them in our previous lessons. We're going to get a little bit more detail into it now. I'm going to show you a more detailed version of the rock cycle, and then we will, over the next few lessons, focus in on each individual type of rock. So, basics of rock types. We have 3 classifications of rock. Hopefully you remember this from the last lesson. Igneous, sedimentary, and metamorphic. We're going to focus on igneous today, but we're going to take a look at some of the basic properties of each of them before we start. Igneous rocks are going to form whenever magma cools off and solidifies. So it's basically going to turn from a liquid into a rock. Please excuse the dog in the background. He is upset that people are on our streets. So magma reaches a point where it's going to cool. So typically it's going to come to the surface, become lava, cool off completely, and solidify. Remember that magma is molten rock, gases, and water vapor under the ground. Lava is basically magma that flows out on the surface. It comes from the volcanoes. We have 2 types of igneous rocks, intrusive and extrusive, and we're going to take a look at what each one of those types is coming up here. So here are some images of igneous rocks. You will need to be able to recognize some of these on the test. So I would make a note of this slide in your notes so that you know to come back to today's date, basics of rocks slides, and take a look at these images. There are guaranteed to be test questions that show you a picture and say, what type of rock is this? Alright, so 2 types of rocks, intrusive and extrusive. We're going to start off looking at extrusive. These are going to be things like rhyolites and basalts. There are images of both on the right-hand side. Rhyolite has kind of a reddish color from the iron content. Basalts, remember, are ocean floor type rocks. So, extrusive rocks. They're going to form on the surface of the earth. They're going to cool very quickly, and they're going to have small, fine crystals because they do cool so quickly. The faster it cools, the smaller the crystal. So these are going to be things that you're going to find near the surface of the earth. Things that we're going to walk around on, or ocean floor. Right here on the surface. They're not going to be very deep. Intrusive rocks, on the other hand, are going to be underground. They're going to be deeper down in the crust. They're going to be more of like a bedrock kind of base. They're going to form underground. They're going to cool more slowly. Because they're deeper under the surface of the earth, they have higher... because they're deeper under the surface of the earth, they're going to be in locations that are higher temperatures, so it's going to take them longer to cool off. And then, since they cool off so slowly, you're going to get much larger, more coarse crystals. So they're not going to be as fine. You're going to have coarse crystals that are a lot larger. So fast cool time, fine small crystals. Slow cool time, coarse large crystals. Here are some examples of intrusive rocks versus extrusive rocks. Again, you not only need to know the types of rocks, but you will also need to know their classification, whether they're intrusive, extrusive. And then also, you'll see on the last slide of the day that you're going to have to be able to give them a classification by the type within the umbrella of igneous rocks as well. So we'll talk about things like felsic versus mafic coming up on the upcoming slides. So recognize the names of these rocks based on what you see. And we will talk a little bit more about the properties when we get into that specifically. Sedimentary rocks. These form whenever sediment is squeezed together. So you have lots of particles and they are all pushed together under pressure to form the solidified rock. Sediment are small pieces of material from other rocks or organisms. It's usually been chipped away by either weathering or erosion. So we have three types of sedimentary rocks that we are looking at. The first type of sedimentary rock is called clastic. Clastic rock forms from broken pieces of other rocks. So when things get chipped off of other rocks, that is going to be a clastic rock when those get forced together by pressure. And they're going to be cemented together, and so you'll be able to see all of these different pieces and types of other rocks all together in one new rock form. So that is a clastic rock. We classify those based on the size of their particles, so small, medium, large particle clastic rocks. Second type is chemical sedimentary rocks. Those form whenever minerals precipitate out of solution. So if you have rocks that are being eroded away by water or dissolved by acids, those kinds of things, the minerals are going to precipitate out and then they'll reform into a new rock, and that is a chemical sedimentary rock. Organic sedimentary rocks form from animal shells that are going to collect together and be compacted to form into a rock that way. Some examples of sedimentary rocks here. Again, be able to recognize the different types. So these are sedimentary rocks formed from particles being forced together. The next type of rock is metamorphic rock. This is our second major classification of rocks. These are rocks that change from one form to another because of pressure, temperature, or reaction to water. They can be formed from any type of rock. You can have any one type of rock change into another through metamorphism. They're usually forming deep underground. Metamorphic rock comes from deep underground. That's where you're going to get the high enough pressures and temperatures to have that metamorphism happen. They're going to create either foliated or non-foliated rocks. Metamorphic rocks are generally going to be foliated. They're going to have crystals that are lined up in parallel layers. Examples of metamorphic rocks. So with the rock cycle, you already did a little bit about this in the previous lesson. We're going to get a little bit more detailed into it. And the very last slide is going to be one that you're going to need to copy down, and you're just going to add it to your previous version of the rock cycle that you've already drawn. So, first of all, it is a process of changing from one type of rock to another over time. We talked about a very basic version of the rock cycle with one pathway through it in our previous lessons. I'm going to give you another example of a pathway through it here, and then we're going to take a look at the other possible pathways on the final slide. So, one example would be you have magma underneath the surface, deep within the earth. Magma is going to rise up, it's going to cool off, it's going to solidify and form igneous rock. Once it does that, the igneous rocks are on the surface. You have weathering and erosion happen that breaks them down into sediments. The sediments are going to be squeezed together as they join up. They're going to form sedimentary rock. That sedimentary rock is going to be buried. It encounters large amounts of heat and pressure. The deeper it gets into the earth, into those lower regions of the crust, it's going to encounter heat and pressure. That's going to change the sedimentary rock into metamorphic rock. As it continues to get pushed down deeper into the layers, it heats up, it melts, and becomes magma again. And now we're back at the start of the process. Again, this is a cycle. It's going to keep going around and round, and it can go any direction back and forth. This is just one scenario in the rock cycle. You can start it anywhere, and there are multiple paths you can take through the rock cycle. So here's an image of the detailed rock cycle. You should have already created an image of the basic rock cycle in your previous notes. Go ahead and refer back to that and just add the new directional arrows to that same drawing. You don't have to redraw it. Just add the new arrows to it so you have all of these, and then make sure that you make note of what page it's on so that you can study that, because there will be questions on the test about the different paths through the rock cycle and how rocks change. Once you are done with that, you are done with these notes, and then you're ready to move on to the homework assignment. So the homework assignment then is to complete this assignment about rocks and the rock cycle. And this is what it's going to look like. When you get into this, it's one of those NADA quizzes. So you're going to come in here and you're going to have some true false, you're going to have some matching, and you're going to have some multiple select. There's only 4 questions. It should not take you more than 5 minutes to do this. They are completely based off of the notes. And you can take it as many times as you need to get a grade you are happy with. When you're done with this, go ahead and move on to the Igneous Rocks focus and take the notes for that, which is where we're headed now. Alright, so we are now going to focus on igneous rocks, and these are a little bit more detailed. There's a lot more slides, but a lot of them, again, are images, so it's not as much as it looks like. So these first couple slides, you don't have to write. It's just telling you what to expect and what we expect for you to get out of it. So we want you to know the genetic classification of intrusive versus extrusive. You don't need to know that it's called genetic classification. You just need to know the difference between the two and what their characteristics are. And again, felsic versus mafic, you don't need to know its compositional classification, but you do need to know the properties of each. And then learn how to use the Igneous Rocks chart to find classification, composition, all of that. So, you should already be able to answer these questions. What are igneous rocks? They're formed from cooled lava or magma. They're classified based on how they cool. And then we have our nice little T-chart here. If you've not already gotten this down into your notes, you need to copy this T-chart down. Intrusive rocks cool slowly, form deep in the Earth's surface, and they come from magma. Extrusive rocks cool quickly, they form on the surface, and they come from lava. So now here on slide 4, this is where you're going to want to start writing some things down if you had already had the material from the previous few slides. Extrusive rocks. They form on the surface, but they can also be erupted from pyroclastic material. Remember that pyroclastic material is the stuff that's shot out of volcanoes. Fragmented pieces of magma that are ejected into the air and cool off as they're flying through the air. These are some examples of different types of pyroclastic material. You can have the really fine stuff called ash. You can have these stones that look like they're full of holes. That is pumice. And you can have things like scoria here, which are more of a dark brownish color. Those are all extrusive rocks that are pyroclastic. There are a couple of special types of extrusive rocks. You have obsidian. This is a rock that has cooled so fast that you don't have any crystals. Typically, when you cool a rock, you are going to form some type of crystals. Obsidian is the exception. It is one solid, smooth. It almost looks like black glass, but you can't see through it. Pumice, on the other hand, is very rough, very dull. It's got a lot of holes in it where gas bubbles were trapped, and they call it a vesicular texture. This is kind of what your alveoli look like on the inside of your lungs, actually, is you have all these little sacs and things in there. But all of these little holes in it are from gas escaping from it. So this image is just giving you examples of intrusive versus extrusive rocks and showing you where they form at. So intrusive rocks are going to form down here deeper in the earth. Extrusive rocks are going to be up here on the surface and ejected from volcanoes. There we go. So, 4 different types. Please get these written down and know some examples of each. Okay. So, intrusive rocks cool very quickly. They fracture and crosscut a native rock. So native rock means the rock that's usually in that area. Intrusive rock comes from some type of magma moving into the space. So it's going to invade that space. Anytime you have something hot like magma invading a space, it is also going to cause contact metamorphism, which we'll talk about a little bit more when we do the metamorphic rock lesson. But around the edges, if you look closely, you'll see there's like banding around the edges where the rocks are actually changing. And it's because that heat from the magma is causing the native rock to undergo those changes. But you have a granite intrusion here, this lighter color, and then you have the darker color around it. And then you have some of these yellowy patches here. So this white is your granite intrusion. You have the yellowy patches around it that are the metamorphic rock, the sedimentary rock that was local being changed due to the heat. And then you have these dark areas that are the natural sedimentary rock. So you can actually see a little bit of all of it there. Classifying igneous rocks. We can look at their chemical makeup and their mineral composition. So chemistry-wise, they are silicon and oxygen. Mineral-wise, we are going to consider them either felsic, which has a high silica content, all the way down to ultramafic, which is a very low silica content. So from high to low, it is felsic, intermediate, mafic, and ultramafic. Felsic has the highest amount of silicas, and you get less and less all the way down to the ultramafic. And we're going to see a table about this coming up here, so you'll see kind of what that means. Felsic rocks are generally found in continental crust. Mafic rocks are more going to be oceanic crusts. Ultramafic is going to be down near the mantle. So, felsic igneous rocks. These have high silica content, low iron and magnesia content. They're usually lighter colors. They're very rich in minerals. So you have rhyolites and granites. The coloration is going to be dependent on the minerals that are present. So high silica, lighter colors. Mafic rocks, on the other hand, are going to be high in iron and magnesium and low in silica. They're going to be darker colored. The more iron you get, the darker it's going to get. The more magnesium you get, the darker it's going to get. So these darker rocks like the gabbros and the basalts have very low silica, high iron magnesium content. Some minerals that are found in these types of rocks are listed here. We are going to see a table that has all of this on it as well, but it's a good idea to just kind of become familiar with the minerals that can be present. You have felsic on the top, mafic down here under the line, and you can see what minerals are present there and what their chemical composition is. I would go ahead and jot this down in your notes. Intermediate rocks. Intermediate igneous rocks are in between felsic and mafic, so they can be a kind of a mix of colors. You'll have some light colors, some dark, all in the same rock. Ultramafic. These are going to be very, very low silica content. These are going to be predominantly mafic minerals. Peridotite here is an example of one of the ultramafic rocks. And then again, we have our table here. So, felsic rocks, light color, low density. Some common minerals: quartz, orthoclase, feldspar. Intermediate rocks, they're middle of the road for color and density. They could go either way, have parts of both. For the colors, you'll have some light, some dark. Intermediate density, so middle of the road density, and then plagioclase, feldspar, biotite, amphibole. Mafic rocks are very dark. They're high density. They have olivine and pyroxene. And then ultramafic are as dark as we see. Very, very, very dark. Super high density, and they usually are simply only olivine. I would get this down in your notes as well. Several tables and charts today. On this slide, I'm going to let you guys click through this on your own. It is types of rocks along with the minerals in those rocks. You will need to be familiar with this. So as you click through this, I would jot down some of these minerals that are found in it and reference back to this slide and just do, 1, 2, 3, 4, 5. Go through and make sure that you can recognize these rocks and that you can tell me what kinds of minerals are in those rocks. So go through and do that for all of these. Alright, so this is our final slide. This is a table where you're going to put all of that information together and try and figure out what these rocks are or what they're composed of based on the information you're given. So what you've got here is at the top section, we have the composition, felsic, intermediate, mafic, ultramafic. You have rock types. This middle line is going to be intrusive. The bottom line is extrusive. See that there is no extrusive ultramafic. Make note of that. If you were to draw a straight line down from this, you would see composition. So everything that is a felsic rock could have any of these minerals: orthoclase, feldspar, quartz, plagioclase, feldspar, muscovite, biotite, amphibole. Those are all possible minerals to be found in a felsic rock. Over here on the right-hand side, if you draw the straight line down, ultramafic is going to be completely pyroxene or olivine. So that's how you read that part. They may ask you what type of rock has orthoclase, feldspar, and plagioclase, feldspar. And you're going to answer with felsic or intermediate, whichever one they have. There's a little tiny piece of orthoclase, feldspar, and intermediate here, up here at the top. So right in here. Typically, if they're going to have both, it's going to be the felsic. But you will have very clear answers on it. It will say, does a felsic rock have pyroxene in it? Or it will say, which of these minerals does felsic rock contain? And it'll list all of them out, and you'll pick the right ones. So be able to answer questions based on this part of the chart. The arrows at the bottom are going to tell you silica, iron, sodium, potassium, all of those levels. So high silica content is going to be over here on the left where the arrowhead is. Low silica content is over here on the right where the arrow tail is. So as you move to the left, you increase the silica content. Same thing with sodium and potassium here in the blue. As you get to this kind of orangish arrow, you see they switch directions. So iron, magnesium, you increase the amount as you move to the right. Same thing with melting point. Higher melting points are off to the right. Higher melting point means it's a solid longer. So you can go deeper into the layers of the earth and still find it a solid. So that's how you read this chart. Once you have this under control, you're going to come over here to this assignment. And you're going to go to this Classifying Igneous Rocks assignment page. So you're going to click here to make a copy for yourself. And then these are the questions you're going to answer on your paper. Once you've answered these, you will submit it the normal way. In order to answer these, you are going to use these tables at the bottom of the page. So you can see arrows that give you color and density, composition. You can see the makeup of them, the texture, and then you have this table here again that gives you the classifications. So you can use both of these. If you are uncertain of how to do this, you can go back through and watch that part of this video again, or you can also scroll down, and down here in the notes there's another video from someone else who has posted on YouTube to help explain how to use those tables as well. So feel free to go use this one if you need to as well. So you have your two assignments here, Rocks in the Rock Cycle plus Classifying Igneous Rocks, that you're going to turn in. And once you've turned them both in and you've completed both sets of notes, you are done for the day. We will see you next time.